Hello everyone. Today in this video we are going to discuss the problem hotel queries. Let's discuss what the question is asking. There are n hotels on a street. For each hotel you know the number of free rooms. Your task is to assign hotel rooms for groups of tourists. All members of a group want to stay in the same hotel. The group will come to offer to you one after another, and you know for each the group the number of room required. You always assign a group to the first hotel having enough rooms. After this, the number of free rooms in the hotel decreases. In simple words, we are given an array H and given an array R. So what we have to do for each R of I, we have to find the first H of I which is greater than equal to R of I. For if we see in this example, the first index where uh, H of I is greater than 4, it is this third inside in indices. Then what we have to do? We have to decrease its value. I will show you. See, first we have 3, 2, 4, 1, 5, 5, 2, and 6. Now 4 comes. So we have to find the first index where its value is greater than equal to 4. So we find this index is 3, 1, 2, 3. So its value will be decreased by this value. So it will be 0. So next this 4 comes. Again we have to find a value greater than equal to 4. This come to this index, its index is 5. It will be decreased by 4, so its value will become 1. Now again we have to find a value greater than equal to 7. We have no value, so for this, if there is no value greater than equal to R of I, we have to print 0. Next 1. So this is the first index which is greater than equal to 1, so it will be decreased by 1, so it will become 2. Now again 1 comes, we have to find index greater than equal to 1. So the first index which is 2 greater than equal to 1. So it will be printed the indices and the value will be decreased by 1. So the resulting value of the first index will be 1. So for solving this problem you should have a prerequisite and you should have a in-depth concept of the data structure known as segment tree. That is how segment tree is constructed and how we do a point updation in segment tree. You should know. Although I am going to discuss all about it in this video, but you should have at least learned what is segment tree. So what we are going to do in this question, we will store uh, each segment or each range from L to R. What's the maximum number it have? Like if we have 3, 2, 4, 1, 5, 5, 2, and 6, right? Is its indices are 0, 1, 2, 3, 4, 5, 6, and 7, right? So what we are going to store in the segment tree, we want to find what's the maximum value it has from indices 2 and 4. So the segment tree vector should return 5 because from 2 to 4 the numbers are 4, 1, and 5, and the maximum number between all of this is 5. So what segment tree does, it just give some particular value in a particular range. Segment tree is used for range query, and here we are requiring the maximum value between a particular range. So by having a value, maximum value between a particular range, what it will be useful in this problem. See, we have this indices and now we want to have the maximum, the minimum indices which have a value greater than equal to 4, right? So we know how segment tree is constructed. So first there it will be a node which will carry from 0 to 8, 0 to 7, and then it will have two subtrees. One will have 0 to mid, it will be 0 to 3, and other will be have mid plus 1 to R. So this will store max value from mid plus 1 to R, that is 4 to 7. Similarly, it will break into two indices. This will be from 0 to mid, that is 0 to 1. Again, it will break to 2, it will be from 0 to 0. And this will also from 1 to 1. It is the leaf node. Similarly, this will be from 2 to 3, and this will be from 2 to 2. This will be 3 to 3. This will be 4 to 5. This will be 4 to 4. This will be 5 to 5, and so on. It will take a lot of time to construct the means to show the construction of segment tree. Now we know what we are storing. We are storing the maximum value from range L to R. So in this leaf node, the maximum value will be the value assigned to the each node, right? So the 0 value from range 0 to 0, its value should be 3. All the leaf node should have the original value, which is restoring 2, 3, 2, 4, 1, 5, 5, and when it will be like this, it will have 2 and 6, right? So when it will traverse back after having DFS to its children, it will store the maximum of 3 and 2, that is 3. This will also store maximum of these two, that is 4. So it will return 4. Not returning, it will just find what's the maximum value of left and 4, left and right. So here it will store 4, and we can also see that from indices 0 to 3, that is this, the maximum values is 4. So after construction of this segment tree, what we have to do now, if suppose 4 comes as in our given sample example, this will be 6 because maximum value of entire array is 6. What we are going not to do, first we will find, as we know, the root element will store the maximum value of the entire array, right? So first we will check whether the maximum value of the entire array is greater than the given R of I or not. If it is greater than R of I, then we know there uh, is a particular value H of I which is greater than R of I. If the root value itself is less than R of I, then it shows that there is no value in the particular array which is greater than or equal to R of I. Then in this case, where the root element, that is, if we denote segment tree as ST, if the root element is less than a particular R of I, then in this case we have to print 0 because there is no value, and when there is no value present greater than equal to R of I, we have to print 0, right? This is the first case. Now if it is greater than or equal to R of I, then we know there is a index where the value is greater than or equal to R of I. So for finding the value which is greater than equal to R of I, what we can do, because we can travel from the root node and we will find whether the left child is greater than or equal to R of I or not. Why so? Why we are giving preference to left? Because we have to find the leftmost index where it is greater than or equal to R of I. So if we find that there is a particular element in the left which is greater than or equal to 4, then we will uh, go means travel to the DFS in the left subtree, and we will not go in the right subtree. So now here we know there is 4 in the subsegment 0 to 3. So we will now also check where the 4 is lying in the left part or right part. So we will give preference to left. We will find whether 4 is present in the maximum value 4 is present in left subtree or not. We find that there is no element greater than 4 in the left subtree. So we will not get answer from here. So we will traverse to the right subtree. Now here we know 4 is there. So again we will go to left, and here we find that there is a 4 and it's a child. So we will return the index of this element, which is 2. So answer for this particular query of 4, it is index is 2. It's a zero base indices. So after converting to one base indices, it will be 2 plus 1, that is 3. Right? Again, then after doing this, what we have to do, we have to update our segment tree. How the current value of that particular node was 2, and after decreasing the value by r of I, it will be 0. So what we will do, we will decrease the value of this particular node by 4 and it will become 0. Right? So the next question comes, how we can update a particular node in the given segment tree. So for doing that, what we have to do, we have to just use the update function. What we do in normal segment tree, we have to just a point update of a particular node. So this was all over the basic concept required to solve this problem. I will show you the code, what I have done. So see, just I have taken n and m as input and created two vector h, which will be storing the hotels, and r of I will store the number of groups of people that are coming. I have taken the input. Then I have constructed a segment tree, and means make a vector of segment tree, and then here I have constructed a segment tree where I am just assigning the maximum value of a particular node. If it is a leaf node, then maximum value will be the um, given value. Otherwise, we will find the left. We will be recursively calling the left subtree and right subtree, and if the left one is greater than the right one, we will be assigning the value to the left one, otherwise the right one. After construction of segment tree, we are just applying a loop from 0 to m minus 1, and we are finding whether the root element is smaller than the given r of I. It is smaller than, we know that there is no particular value in all over the h of I, so we will just print 0, otherwise we will find the element index which will have the particular value, means first leftmost indices which has value greater than equal to m. So I have make the findAD function which will return the leftmost indices which has value greater than equal to r of I. So for doing this, it's just a simple DFS. If it's a root, then we will return the indices of the particular root. Otherwise, we will find whether the leftmost. See, we are here giving preferring the leftmost left subtree because we have to find the leftmost part. If the question was asking the rightmost part, so here we only have to do one change. Instead of first giving preference to the left tree, we have to give preference to the right tree. Okay, so after finding whether the left subtree has value greater than equal to m, if it has. So we will find that in the particular left subtree, otherwise we will find in the right subtree. So it will return the indices. After we will print the indices and we will decrease the value of particular indice, and then we will update the value. For updation, it's a simple segmentary updation point updation code. We are just passing the new value for what we have to update, and when we will go to the leaf node, we will simply update the value, and for every non-leaf node we will just say what's the maximum value, what a particular range will carry maximum value. It will be the maximum of left subtree or right subtree. So this was the accepted code. I hope you like it. If you have any doubt, you can ask me in the comment section. I will definitely try to answer each question. Thank you.